Hello guys. So in this session we are going to learn Elasticsearch interview questions and answers. Okay. So in this session we will see Elasticsearch, that is ELK stack interview questions and answers, and organize across basic architecture, features, use cases and troubleshooting. Okay. So let's start. So first of all we are going to learn ELK stack, right? Okay, so let's start. So first of all, what is Elastic Stack? That is, what is ELK stack? Okay, so as you know, what is ELK? So Elastic Stack, formerly known as ELK stack, is a collection of tools: Elasticsearch, Logstash, Kibana, and bits. So in bits, there is a file bit, metric bit, and so on. Okay. So it used for centralized logging, monitoring, and data visualization. Okay, it helps ingest that data from multiple sources, store it efficiently, and analyze it in near real time. Okay, so that's the simple definition of ELK stack. Okay, then what are the core component of Elastic Stack? Okay, so what are the core components? So first is Elasticsearch, Logstash, Kibana, and Bits. So what is Elasticsearch? It is distributed search and analytics engine. Logstash parses and transform data. Kibana is a visualization and explore data, and Bits lightweight agent that ship data, Logstash or Elasticsearch. Okay, so that's the core components of ELK stack. Okay, Elastic stack. Okay. Then next is, what is Elasticsearch? Okay. So what is Elasticsearch? Elasticsearch is a distributed RESTful search and analytics engine capable for addressing and growing number of use cases. And it stores data in JSON format and uses a powerful query language. And as you know, Elasticsearch port number is 9200, right? Right. When we access Elasticsearch in browser, then the port number of Elasticsearch is 9200. Okay. Then next is Logstash. What is Logstash and what are the roles? What is the role in Logstash? Okay. So Logstash is a data collection engine that supports a wide variety of inputs, filters, outputs. Okay, and it helps pass and transform logs before forwarding them to the Elasticsearch. That's the Logstash. Okay. The next is Kibana. So as you know, Kibana is used for visualize and explore data, right? Okay, so Kibana is a web interface for Elasticsearch. It is used to visualize data, create dashboard, run queries, and monitor the health of the Elastic stack. That we learn in previous session, right? And as you know, Kibana port number is 5601. That's the default port number of Kibana, right? Okay. The next one is, what is bits? What are the bits? Okay, so bits are lightweight agent installed on server to collect or ship data or to Logstash or Elasticsearch. Okay, so here I mentioned some examples of bits. So what are the bits examples? First is file bit, metric bit, and packet bit. Okay, what is file bit? File bit reads logs files. Metric bit collect metrics from system and services, and packet bit is analyze network traffic. That's the role of file bits, and that are the types of bits. Okay. The next one is, what is the default port number of each Elastic Stack component? Okay. What is port number? So Elasticsearch port number is 9200. Okay. So and REST API is 9200 for REST APIs and 9300 for cluster. Okay. Then Logstash is 5044 for bits, inputs, and varies of config. Okay. And as you know, the Kibana port number is 5601 and bits. Okay. Output of bits is 5044 Logstash or 9200 for Elasticsearch, because bits are collect the ship data to Logstash or Elasticsearch. So that's why in this bits there is a two port number. First is Logstash and second one is Elasticsearch. Then next is, why Elastic Stack used for? Used. Okay. Why we are use Elastic Stack? So Elastic Stack is commonly used for logging aggregation, real-time monitoring, full text search, anomaly detection, securely analytics, and infrastructure observability across distributed system. Okay, that's why we use Elasticstack. Okay, the next one is what data formats does Logstash support? Okay, so Logstash can pass data in JSON, CSV, XML, plain text, slog, and custom formats. Use plugins and graph filters, enabling flexible log transformation and enrichment. That's the format used in Logstash. Okay, then what is pipeline in Logstash? As you know, pipeline. So pipeline defines how Logstash process data in using three stages. First is input, second one is filter, and third one is output. Okay, input data ingestion, filter transformation, output data delivery to target like Elasticsearch. Okay. Then next is what are the grok filter in Logstash? So grok is a powerful pattern matching syntax used in Logstash filters to pass unstructured log data into structure field. Okay, so it's essential for extracting fields like IP address, timestamps, and user agent from raw logs. Okay, and the last one is how do you deploy Elasticstack? So you can deploy Elasticsearch using Docker, Kubernetes, and Elastic Help Chat also. Okay. So or directly install the binaries Linux Windows system. So that's the way you can deploy Elasticsearch. Okay. That's the about Elasticsearch. Okay. Now the next one is now we are going to learn about Elasticsearch architecture and the concepts. Okay. So let's start. So first of all, let's explain Elasticsearch indexing. Okay. So Elasticsearch store document in indices. Each index is a logical namespace containing one or more starts, primary and replica. Okay, which hold actual data and it uses inverted indexing to make search fast. Okay. Then what is document in Elasticsearch? A document in JSON object that is stored in an index. So it represents a unit of data like a log entry or product description, and it is uniquely identified by an ID. Okay. Then next is about Elasticsearch, that what is the Elasticsearch index? Okay. So an index in a collection of documents that share similar characteristics and is a analog to a table in a relational database, and each index is a split into shards for scalability. And what is shards and why it is important? So it's a horizontal partition of data. Elasticsearch uses shards to distribute data across multiple nodes for performance, scalability, and fault tolerance. Okay, what is replica shard? A replica shard is a copy of primary shard. Okay, used for failover and load balancing. Elasticsearch ensure high availability by assigning replica shard to different nodes. Right. Okay. Then next one is what is the difference between primary and replica? Okay. So primary shards hold original data while replica shards are copies of for redundancy and are used to load balancing read requests. That's the difference of this to this both shards. Okay. Then next one is what is node and cluster in Elasticsearch. Okay, what is node? So node is a single instance of Elasticsearch, and what is cluster in Elasticsearch? So a cluster is a collection of nodes that work together, where one node is elected as a master to manage metadata control tasks. Okay, that's the node and cluster in Elasticsearch. Then what is the role of master node? Master node manage cluster metadata such as node, joins, leaves, and index creation, shard allocation, and over cluster health. Okay. Then how is data distributed in Elasticsearch cluster? So data is distributed automatically using shard across nodes. The cluster coordinator ensure proper shard allocation and recovery. Then next one is, how does Elasticsearch handle search requests? Search requests are sent to a coordinating nodes which distributed our requests to all relevant shards, both primary and replicas. The types of shard is two, right? Primary and replica. Okay. Then merge and result before returning them to the client. Okay. Then what is difference between keyword and text field in Elasticsearch? Text fields are analyzed and used for full text search. Keyboard fields are not analyzed are and used for exact matches, sorting and aggregations. That's the difference of this text and keyword. Then how does Elasticsearch handle schema? Elasticsearch uses mapping to define how document and their field are stored and indexed. So it can detect field types automatically. Dynamic mapping or to be configured manual, that is explicit mapping. Automatically or manual. Okay. Okay, so that's about index architecture and index about Elasticsearch. Okay, now the next is, let's learn about Kibana and visualization. And as you know, Kibana is used for visualizing and explore data. And in Kibana, we have learned that dashboards to show the data of our servers, right? Like graph and so on the details. If you watch my previous video session, then you can got the point that what is Kibana. Okay, so let's understand what is Kibana in detail. So first of all, what is Kibana and how does it interact with Elasticsearch? Okay, so Kibana is a web UI, right? User interface for Elasticsearch. It helps user create dashboard, run queries, visualize data, and manage index pattern, and allowing insight to be extracted without using raw queries. Okay. Then what are Kibana dashboard? So dashboard are customized collection of visualize like charts, map, tables, and etc. Okay, that provides insight into data from one or more index patterns. That's the dashboards. Okay. Then what is an index pattern in Kibana? So an index pattern tells Kibana which indicates the Elasticsearch to explore for visualization, and it define how the data should be interpreted and what fields are available for analyze. Okay. Then what are the types of visualization are available in Kibana? Kibana supports various visualization types such as line chart, bar chart, pie chart, heat maps, data tables, and more, and so on. Okay. It supports Vega and TSVB for advanced use cases. Okay. If you use Kibana, then you can understand in detail. Okay. Then what is KQL in Kibana? Kibana Query Language. The full form of KQL is Kibana Query Language is a simplified syntax to search and filter data in Kibana without using full syntax. Okay, full lines of syntax. Then, can you secure Kibana access? Yes, you can secure your Kibana access using Elastic Security, XPack, or open secure source tool like Nginx reverse proxy with basic authentication. Then you can also implement role-based access control, that RBAC, for general user privilege, right? Angular, okay. Then okay, so that's the about Kibana and visualization. Okay, so in short, Kibana is for visualization and exploring data. Okay, then next one is bits and data ingestion. Okay, so what is file bit and how it is used? Okay, So in this bit, there are three types: file bit, metric bit, and packet bit. Okay, so first, what is file bit? File bit is a lightweight shipper that reads logs line by line from lines and forward them to Logstash or Elasticsearch. Okay, and it is efficient and designed for minimal resource consumption. That's the file bit. Then what is metric bit? Metric bit collects metric from system and services like CPU, memory, Docker, Apache, and etc. and sends them to Elasticsearch. And the next third one is what is packet bit and what is used for. So packet bit capture network traffic, decodes protocols, example HTTP, DNS, right? And send structured network data to Elasticsearch. That's the use of packet bit. Okay, so can bits send data directly to Elasticsearch? Yes, bit can send data directly to the Elasticsearch or through Logstash if pre-processing is needed. Okay, that choice is your. Okay, then how do you manage bit configuration? Bit configuration are YAML files. You can define modules, inputs, processors, and outputs that Logstash or Elasticsearch in these files. Then how does FileBit handle log rotations? So FileBit tracks file offset using registry file, and it resumes reading from correct location after a rotation or restart. Okay, that's the handle log rotation. Then, what are the different types of bits? File bit, metric bit, packet bit, hot bit, winglog bit, and audit bit. Okay. So for file bit, as you know, for log files, metric bit for system and service metric, packet bit for network traffic, hot bit for uptime monitoring, winglog bit for Windows event logs, and audit bit for audit data. That's the different types of bits. Okay. Okay, that's the about bits, file bits and about the bits. Okay, now let's understand advanced features and use cases. Okay, so first of all, what is index lifecycle management? Okay, ILM. So, index lifecycle management automates the aging process of indicating using lifecycle policies like hot, warm, cold, delete to optimize storage and cost, and it help managers time series data efficiently. Okay, then what is the purpose of ingest pipeline in Elasticsearch? So pipeline allow pre-processing of data before indexing using process like gawk, rename, set, and GOIP. Okay, helping you eliminate the need for log slash in some cases. Then, how does Elasticsearch achieve near real-time search? Elasticsearch uses refresh interval, default 1 second, that makes newly indexed document searchable shortly after being indexed, providing near real-time performance. Okay. Then here, can Elasticsearch perform aggregation? So yes, Elasticsearch can perform aggregation and it supports powerful aggregation such as metrics like average, sum, count, and buckets like term, data histogram, and pipeline aggregations for post-processing the results. Okay. So what is the role of coordinating node in Elasticsearch? So coordinating node handles incoming requests, distributes them to relevant nodes, gathers result, send back to the final response, and it doesn't hold the data itself. That's the role of coordinating node in Elasticsearch. Okay. Now, how do you scale Elasticsearch? So Elasticsearch can be scaled vertically and horizontally. Vertically by adding resources to nodes, and horizontally that by adding more nodes and redistributing shards for load balancing. Then What are the aggregation in Elasticsearch? Aggregation summarize data like average, sum, count, term, data histogram, and are used to analytics and visualization. What is the role of upgrade in Elasticsearch? So rolling upgrade allows to upgrade nodes at a time without downtime, assuming version compatibility is met. Okay. Then how do you handle large time series data? Use time-based indicates, apply ILM, right? Then use roll-up indicates, and I say sorry, and avoid high cardinality field for efficient storage and search. Then how does Elasticsearch handle versioning of document? Hmm, okay. Each document has a version number that increment on update, and you can use optimized concurrency control via version. Then what are the watchers in Elastic Stack? Watchers allow you to define alert and action based on the condition. For example, alert when you disk usage exceed 80%. Okay. Then troubleshooting and bits practice. Okay. Now it's done. Okay. Now next one is let's understand what is troubleshooting and best practices. Okay. So how do you check Elasticsearch cluster health? So use get cluster or health. It returns green, yellow, or red. Okay. That indicating overall cluster health and shard status. Okay. So what's the meaning of this color? Yellow, red, or green? Okay. Let's check. Yellow means replica shard unallowed. Red means primary shards missing or data unavailable. So causes include node failures, disk limits, or configuration error. That's the meaning of this. Okay. Then how to troubleshoot failed logstash pipelines. Okay. So logstash logs, you can see the path of this. Then syntax error in config, after that, plugin compatibility, then input output connectivity, and pipeline debugging with config.text and exit. Okay, that's the troubleshoot fail. Okay, then next is why are some field missing in Kibana visualization? This may happen if index mapping changed recently, file types mismatch, index pattern was not refreshed. Then go to the Kibana stack management. After that, index pattern and click on refresh fields. Okay. And then after that, next is Elasticsearch memory uses is high. What we can do? So first of all, increase JVM heap size, but keep it 50% of total RAM. Okay. Then use filter instead of queries where applicable. Then limit deep recognition and aggregation. Then use data types and ILM to achieve all data. Okay. Okay. Then how to monitor Elastic Stack performance? Use Elastic Stack monitoring in Kibana. Deploy metric bit with Elasticsearch Kibana modules. Then use nodes or start and cluster health or APIs. Then enable slow query, log and indexing logs. Okay. The next question is how to reduce indexing latency in Elasticsearch. Okay, so first of all, you can use bulk API, then increase refresh interval, tune the number of shards, then disable replicas. Okay, temporarily. Okay, then what are slow logs files? So slow log files in Elasticsearch log slow searches or indexing operations, and you can configure their sold via the elasticsearch.yaml file, that is configuration file. Okay. How to troubleshoot logstash startup file? So first of all, you need to validate config with config.text and exit. Then check missing plugins, example logs at var log logstash, and ensure pipeline syntax is correct. Okay. The next is how to secure data ingestion in Elastic Stack. So use TLS or SSL for all internal communication, enable basic authentication with XPath, restrict public access, and impact role based on access control for data and UI visibility. Okay, that's the way you can secure the ingestion in Elasticsearch. How to handle large scale data ingestion? Use bulk API for efficient indexing, optimize logstash with precision queries, increase refresh interval temporarily, use ILM and time-based indicates, ensure you have enough shards and nodes. Okay. And last one is what are the some common challenges with Elastic Stack? So first challenge is scaling ingestion under high load, retention and index both complexity of logstash configuration, performance tuning like disk queries, and secure setup in production environments. That's the some common challenges with ELK stack. Okay. Elasticsearch, Logstash, Kibana. Okay. So that's it. So that's the question we have learned. If you don't understand, then you can check. And if you install this ELK stack and then practice, then you will understand. Okay. So thank you for watching, and I hope you understand.